Hello everyone, my name is Benjamin Joseph Lee. I'm a participant of Codeavour 7.0. My team name is Benjamin Joseph Lee as I'm the only member in my team. I chose the theme, Clean Energy, Healthy People. Why? Since the search of alternative energy such as hydropower, solar power, wind turbines, algae, or piezo is a continuous effort and I want to be a part of it. I'm particularly interested in piezoelectricity. Even though it has a very simple source of energy, which is human movements, and humans are constantly moving, but it has not been widely developed yet. The main reason is because piezoelectricity needs a specific amount of energy to self-start. For example, in this project we're going to be using Arduino as our power regulator, and Arduino itself needs energy to activate. The problem occurs when the piezo material cannot produce enough energy to run the code in the power regulator. See, Arduino itself needs around 100 until 200 milliwatts of energy. And our piezo material, single piezo material, only produces around 1 until 5 milliwatts of energy. This creates a huge gap between the energy producer and the power regulator. To analyze the potential of the piezoelectricity, we're going to be using the Indonesian KRL during its peak hours. So this is the concept of the Vibra piezoelectricity system. So our first assumption is that we have 40 tiles installed with the piezoelectricity material. And one KRL train holds around 2,500 passengers. And we can assume that 70% of these passengers step on the piezo tiles. So we have the total capture steps of around 1,750 steps. Each step produces around 3 milliwatts of pulse energy. So this is a detailed calculation of the piezo energy. From our source data from a single train arrival, we can conclude that we have 1,750 steps. Multiply that with 3 milliwatts of energy and we get 5,250 milliwatts. And then you can convert it into 5.25 watts of total pulse energy burst. Now we have the initial pulse of 5.25 watts. It will be used for electrification and then we'll be left with 4.2 watts. We'll use that for storage. We'll lose another 1.05 watts. We'll be left with 3.5 watts. And then for system assistance, we have 2.1 watts left. And we're left with 1.05 watts for usable power. However, we have peak period assumption collected over all tiles. With 1 watt per train of usable power, we have 20 trains arrivals per peak period, and multiply that with 40 piezo tiles installed, we have 800 watts. However, if we want this to be more clean, we have total collected stored energy of 720 watts per peak period. This can be used for LED info display for 50 watts, phone charging station for 20 watts, and platform lighting indicators. To prove that piezo can yield electricity, I've coded the Arduino. Now let's see if it's working or not. Now I'm going to explain the most important part of the Arduino's code. So this code detects if the Arduino is given a pressure more than 200, then it's going to set the LED pin to high or turn on the LED light. However, if the requirement of more than 200 pressure is not met, then it's going to turn the LED pin into low. or turn off the LED light. Now we are going to connect our Arduino into our laptop to transfer the code to the Arduino. So you can directly click on connect and then connect the Arduino's USB into your laptop. It's refresh. Connect the device and then press on upload code. When it's uploaded successfully, then you can press the piezo with enough force to generate the electricity. It can be shown with the LED lighting up here. You can talk off the USB and it can still light up. So, meet Vibra. Vibra is an AI-based project that puts piezoelectricity into work. How does it work? Piezo has to be placed in a place where a massive amount of people are present at the same time. Every step from each person will be a tiny source of energy. It has to be collected, and part of it is used to self-start the Arduino or other power regulator. And the rest can be used to light a lamp or display. So where is the ideal location for this to perform optimally? Piezo sensors can be placed in an MRT station, train station, or KRL. My project uses AI image recognition to identify when a crowd forms or a train arrives. By recognizing these visual patterns, the AI detects a peak energy moment and wakes the power regulator from sleep mode. This ensures the system stays active only when people are present, preventing any harvested power from being wasted. So now I'm going to explain the most important code of this project. It is located in the Arduino sprite. So when it receives the begin recognition broadcast message, it will start a forever loop. Inside the loop, there will be two if conditions. The first one identifies in the web camera if there's a train, and if the AI is more than 80% sure, it's going to switch the costume to Uno on or turn on the Arduino in real life. However, if the AI recognizes an empty station and it is more than 80% sure, then it's going to turn the costume to Uno off, or basically turn off the Arduino in real life. Let's try the project. Click the green flag, then start button, simulation. Okay, here it's going to open a recognition window. I'm just going to put it here. I'm going to show an image of a cargo train. Okay, the process begins when people step on the floor where the piezo sensors are installed. The pressure from these footsteps creates vibrations that the piezo sensors convert into small amounts of electrical energy. This electrical energy is then sent to the Arduino, which functions as the controller that manages and monitors the energy produced. After that, the generated energy is stored in a capacitor, which collects and holds the small electrical charges until there's enough power available. Once sufficient energy has been stored, it is distributed to useful outputs, such as a charging station for mobile devices and an LED display for information boards. This process continues repeatedly as more people walk, allowing the system to continuously generate and distribute renewable energy. For future developments, CCTV inside the station can be used as a source of image recognition. Thank you!